bunch of really shiny, complex weldments for you. At the end of the day, I think that it kind of boils down to some rudimentary concepts like we talked about earlier. And I'll show you some kind of quick ways to go about doing some weldment tools as well. But I want to kind of break down some of what we talked about in the panel, and what was asked of me was to show and kind of go through the button clicks of what it looks like with the different methodologies that we talked about during the panel. So I took the time to lay out a very similar looking assembly over and over again, done completely differently from the back end structure. So I've got what I called a simple weldment as an assembly, which was the painful part, a hybrid weldment, and then the combo weldment. And my kind of definitions of hybrid and combo was combo being everything in one basket as a multi-bodied part, the hybrid being you've got some sheet metal, I've got some plates, I've got some purchase components that are brought in as an assembly separately. And the end result and what you're going to see in SolidWorks is largely the same as far as the geometry concerned, right? But I want to show the different ways, the different button clicks that you're going to go through going down those methods. And probably more importantly, the end result when it comes to a print, bill of materials, weldment cut list, and some of the ins and outs of getting the properties where they need to go to get what you're looking for. I'm not going to show you the best way to do anything today, right? I don't necessarily believe in that idea. I like to show the different ways that you can go about things, and if you know a lot of different ways to tackle something, you'll find the one that works for you, right? So, kind of starting at the beginning, a simple weldment itself. I've got an individual part file here. It's just showing a real simple, quick table that is laid out as some structural steels. I can add some gussets, some end caps, things like that to it to kind of finish this out. But getting the overall basics behind that, and not knowing everybody's skill set in the room, I want to kind of start at the core basics there, and then work my way through some of the other stuff. First and foremost, this is using the weldment command. It's using the structural member tools inside of SolidWorks. And if you don't have this weldment tab turned on, you simply right-click here and turn on weldments or sheet metal or whatever you're looking for here. Those are built into every seat of SolidWorks. You already own that if you have a seat of SolidWorks as it plays now. So you can turn those tools on. The weldment command itself doesn't really do much. All the weldment command itself does is say, this is going to be a multi-bodied part. And as far as I can tell, all the weldment command does is it says, whenever I extrude, clear the merge result checkbox, because I'm assuming this is another piece of steel. And it generates a cut list instead of a multi-body list. From there, that cut list is going to be consumed downstream with a series of properties, right? If you forget to click this command, it doesn't matter. The first time you hit structural member, it automatically turns itself on and puts itself at the top level of the tree anyways. So I don't really even pay much attention to that button anymore. The structural member itself is going to consist of anything that you have a 2D profile on that sweeps on any given length within the weldment, right? And those are derived very specifically in tools, file locations, tools options, under weldment profiles here. And you see I've got mine set to the E drive on this computer in weldment profiles. And I want to show you that quick backbone, because I've had a lot of tech support calls where people have this mapped to the wrong folder and then it doesn't work, right? So on my E drive here, I've got weldment profiles. I'm particularly pointing to that top level folder. Inside of that, there's ANSI inch and ISO in my case. Those are the different standards for weldments, right? Inside of ANSI inch, I've got the different folders for the weldment profiles themselves. All of these, with the exception of structural wood, which I created myself, and a couple of these configurable ones down here, are downloadable through the SolidWorks interface over here. It's under the little set of books over here, Design Library. If you've got an internet connection, you click on SolidWorks content, it'll say weldments. You click on that, it'll show you all the standards. If you hold control and click any one of those, it downloads a zip, right? Out of the box, SolidWorks installs with like somewhere around 15 different types of profiles and maybe half a dozen in each folder. If you download this zip for the ANSI inch, it's pulling down like over 10,000 profiles, right? And it's all sorts of different square sizes, rectangular tubing. I'll show you all the backbone on that. So one thing to immediately understand, all of this is not AI, it's AL. Those are all aluminum profiles at the top of the list here, right? And as such, are going to be thinner walled. So if you're looking for steel, that's going to start with C channel on down. And it's got a number of those. It's got some scheduled pipe and things like that in here as well. But for your pure weldment structural members, you're probably going to be using tube square, tube rectangular, C-channel, L-angle are going to be your typical ones. Not every size on the planet is in here, right? So you may need to make some of your own. By far and away, the easiest way to make a weldment profile is to open an existing one, resize it, and hit Save As. Okay? You can absolutely make one from scratch if you want to, and I can show you those button clicks if you want to, but at the end of the day, opening and modifying one's going to be a lot simpler, right? Oddly, the ones from corporate are 4 decimal places on their dimensions, which I find kind of strange considering you can't order steel from any company at 4 decimal places, but I suppose you may as well be accurate in theory, right? So that's the backbone behind how it works. One thing that didn't get brought up in the panel discussion was a new function a few years back that allowed for a configurable weldment profile. So going way back in SolidWorks, if you look in the tube square folder here, this is a separate file for every size weldment profile that I can use, right? So not only its overall size, but its wall thickness on the inside. So you might see 2 by 2 by a quarter, 2 by 2 by an eighth, right? Well, basically any given square tube could be a configured profile, right? So here I've got tube square that's just got like a 6 and a 7 inch right now, but I can open that up and make new configurations and reference those instead. So now you would end up having one tube square that has all the different configs. The major difference to point out there is you have to put that at the top level here with the rest of these folders. If you put this inside of one of these folders, they do not work, right? It grabs the last one that got saved and that's it, which kind of undermines the purpose of configuring them, right? So you want to make sure you get those at the top level, one up from there, and then they'll work from there. I've went and created configurable wood ones, and I'll show you that kind of at the end of my presentation, what I've been doing with those. But it's got 2 by 4, 2 by 6, 4 by 4, things like that in it. So that's kind of the backbone on the setup behind the scenes on this. And I like to show that up front so that, you know, when you get back to work, if these aren't already on your computer, you know where to get to them and how to set that all up. And again, it's under Tools, Options, File Locations, Weldment Profiles. So in this case, I've done just a simple series of 2D sketches. This has got an overall rectangle here. I like the centered rectangle command, building off of that personally. I kicked off a plane and made just one leg sketch to that. Certainly could have been done as one 3D sketch. I'm not a giant fan of trying to draw rectangles on a 3D sketch. Kind of tilts all over the place until you lock down, you know, long axes and things. And I'll show you some demo on the 3D sketching side if you've never seen that. And then I use a structural member to go ahead and sweep that overall square tubing side of things with regard to that overall sketch. You know, and here, you know, you can see I'm going to the outer edge of this thing, so my 2 foot by 4 foot table is getting trimmed off relative to that. I've got 2 separate groups going on here, and that's a necessity as I'm starting to change directions, right? So I can have one group that's all on one plane, the top of that table. As I'm trying to come downhill, I need to add another group within that, right? So, you know, just suppressing this for the time being to show you how I got from point A to point B there. It's actually pretty quick and easy. If you click on the structural member command, you're grabbing the overall tube square sizes. I can go grab 2 by 2, 1/4 inch wall, and they're labeled TS for tube square, and then the overall sizing from there. As you click on the first layout of that, it's going to go grab that profile and extrude that along the length of that line. As you grab the next one, it's going to auto trim the corners relative to that, right? One of the first things I always like to point out with respect to that is you're not locked into what it does, right? I don't know that I like the default personally. It kind of chases itself. I don't know if you can see it well on the projector, but I've got a length of tube that's going from here to here, and the same thing up here. Well, yes, I need 4 of those. I don't really have squared off pieces of steel here, right? There's some other options down here that you can swap on that. You can miter corners, which, you know, look really pretty, but I think you'll find they're a lot harder to manufacture too. And instead of just dropping a chop saw down here now, I've got to cut 45-degree angles. And if you want to be real accurate over 45s, that gets kind of tricky, right? So I've built a few structures this way. They're nice looking, but it's a lot of work, right? For the most part, I do kind of an end joint on things. And if you click on these individual dots here, you can change the individual order that these things trim in, right? So now I can get that front piece of steel coming all the way across there. If I want this back piece coming all the way across this way. And this is completely up to you and how you rearrange the members here. But you'll notice if I go to try to click this one, it won't actually select this member because it's changing direction down in the interface. And that's where I'm going to click this new group. And as I grab that new group steel, it can drop in and create that from scratch coming down. One thing I have noticed is if you go and locate profile after the fact, the auto trim doesn't work. If you do it all in one step here, it'll auto trim and work correctly. Locating the profile goes off of this button down in the corner here. And you may have to scroll depending on your resolution to get down to that. I see a lot of users just miss it because it's off the bottom of their screen. That will automatically zoom you into where the weldment profile is, and then you can pick a virtual sharp corner that it will move and trim the metals up to at that point now. So that became my lower left corner of that steel instead of the center of the tubing, right? And that location is per group. So if I go back to click on group 1 and I click locate profile there, I can have that snap to the outer sharp, right? And then it lays that out. But like I mentioned, it starts to go over the top of itself as you start moving a couple of members around. And that's not the end of the world. If you have something that looks like this when you're done, there's a couple of quick button clicks to fix that. This trim and extend command right here will let you choose bodies to trim. The trimming boundary, you can either trim to another body, that's kind of coping one piece of steel into another, or you can trim to a face or plane that lets you just grab that face and trim off the access relative to that, squaring off that piece of steel relative to that. The last steps I did to lay this part out was just mirroring that around a couple of planes. The big key to remember when you're mirroring inside of the weldment environment is you're going to pick your plane as you usually do in a SolidWorks environment, but you got to make sure you're not mirroring features. There's faces and, more importantly for a weldment, bodies to mirror around. So make sure you're selecting that option, and then you're mirroring those individual bodies about that plane. It's giving you a disjoint body in the multi-bodied environment relative to that. So that's a real quick synopsis of kind of laying this out from scratch. I'm just going to go back and unsuppress what I already had. But that's how I got from point A to point B on something like this. One of the next things I really like to point out is if you're doing a welded table on a fairly regular basis, get this to where you want it to be, set all your properties correctly, save this as a template somewhere. See, a lot of users don't do that, and I see people drawing a very similar table over and over again, right? The whole benefit to a weldment is if I go back to these two sketches, I've got the overall sizes, right? So if I say I want to make this thing 30 inches wide now, it rebuilds and automatically resizes all these members, right? So if I just go to save as, and I change my file type to SolidWorks part template, I can actually save a simple weldment table template into my hard drive, right? And now when I hit file new, I'm getting a table already done. You double click a couple of sizes and spit out this new table to start your framework, right? Of course, that only works in similar but different, but most designs usually are, right? Companies find niches in doing a lot of these things. So that's definitely one way you can speed up design work, right? But again, before you go ahead and save it as a template, it's a good idea to set all the properties correctly downstream, right? I'm going to skip that step for now because I want to show you what you get out of the box with assembly, what you get out of the box with weldment, what you get out of the box with a hybrid environment, and then kind of backfill some of the properties to show they push downstream relative to that. So the overall simple weldment, the main benefits are going to be resizing. You'll notice the cut list over here that's grouping all the like members together. Something to note, these are identical pieces of steel. If I punch a hole in one of these and not the other three, it's going to break these folders apart, and I'm going to have 3 in one folder and 1 in the other, right? It by definition looks at the geometry of that component to sync it all together. If you're on an older version of SolidWorks, you may not get this cut list automatically updating all the time, and there's an option to turn that off in 17. When you right-click the cut list, there's update automatically right here, and then create the cut list automatically. So those are both turned on my machine, so as I make a weldment, it's automatically grouping all these things, right? Missing that, you can either turn it on or just right-click and update manually. There is a performance hit in updating constantly, right? Every time I mirror, it's got to go re-update that, figure out what bodies are the same size, group all those things, right? And you'll start to see a hit in a monster weldment as you do that. So you may want to consider turning off that automatic functionality so that you're just choosing when to group all this stuff together. Because in all reality, the grouping doesn't matter until you want to start putting properties on things and get it onto a piece of paper. So you can do that right at the end before you move over to the drawing phase, right? So that's the basics behind a simple weldment. I took the time to go and model this thing the hard way, I guess, just to show the difference, right? So I've actually got an assembly on the computer as well that was simple weldment as assembly. And this has got the crossbar, the leg, the sidebars in the background, and then the assembly itself. And effectively accomplished the same goal. Obviously, the tree looks a little bit different now, right? I've got an assembly. I'd have a bill of materials relative to this. I have an instance count on the number of legs. I did not use mirror components and things like that. So effectively, I now have this overall assembly with a pile of mates in it relative to that. And I hope that the basics on what you're seeing on the right side of the screen here illustrate how much more work this is compared to building a weldment, right? And it's been a long time since I've seen somebody that really have never even touched the weldment commands and is doing this the hard way. But throughout my 10 years at DASI, it's been a pretty eye-opening experience that people were doing it this way for a long time in SolidWorks. And it's quite frankly painful. If I want to make this thing 2 inches wider, I got to figure out what mates control that. It breaks references. Things are going to become disjoint. I got to remeasure things and then go modify individual part files, right? But the main benefit you can get here is that each individual one of these pieces of steel is going to have its own part number. You can break out individual part numbers if you want to pull a hole in one and not others, and save those off as their own part files that are searchable on a hard drive somewhere, especially when you get into a PDM environment, right? Where weldments, I think, falls down is if I want to find this piece of steel and how many times we've used 2 by 3 by 20 inches long, don't really have a great utility to do that in a PDM environment, right? Because it's not really a where used function. It's just happens to be this weldment member that got used in various different lengths. So while the cut list itself is very useful, it's not incredibly trackable downstream with respect to that. So I won't spend a whole lot of time on the old way of doing things, but just trying to drill home why a weldment is important in that respect. A few other things I took the time to do was kind of break down the hybrid and the combo weldment environments. And again, my kind of definition there is a hybrid. I'm getting into an assembly, a part file, a sheet metal file, and those are coming all together into one final product. And then what I called the combo weldment was one of the things that Andrew was speaking to earlier, where we're just slamming sheet metal and inserting parts inside of one document, right? And probably the biggest benefit of that combo weldment idea is there's one part file in this folder, right? That's the benefit of that tool, is everything's contained in that part, and I made one drawing out of that, right? So if I open that combo weldment now, this is, the weldment from scratch that I've already shown you, the tubes, the mirroring, right, is all in the background. And then on top of that, I went and built a piece of sheet metal here that wraps on the inside, and then I built a plate on the top of that. And then I took the time, oddly, we talked a lot about casters and tap pads. That was not planned. That was just a thing I picked off a MacMaster car this morning. So that's exactly what I did on this, because it's probably one of the more common things, right? And I threw that in there and stuffed it all into an assembly relative to that. So you've got your boss extrude for your pad down there, and then this is actually representing the inserted part relative to that, right? So one obvious upside to, let's say, putting sheet metal inside of this environment, making this piece of steel was relatively straightforward, and I never had to use the measure command at all. Kind of cool idea. I can just say the piece of steel fits in between these two legs. The length of the flange is as deep as the steels. I think the one dimension I used on this thing was it came 12 inches down, right? So if I take a look at this, that's the only dim I have on there, right? I never had to measure anything, and if I resize the table, that piece of guarding comes with it everywhere, right? Pretty large upside to this mentality, right? Downside, get a flat blank out of this out to the shop, right? And that's kind of what we were speaking to out in the breakout session earlier, right? So kind of showing that from scratch, if I was to make another one over on this side, I can just take a rectangle and use sketch relationships to define a lot of this stuff, or even put in your weld gaps and things. I'm going to use collinear relationships as I'm making these geometries here. One of the trickier things on weldments you got to watch out for is, you're not trying to snap necessarily to this edge, right? I'm trying to get into that inside corner where the edge of that fillet round is. And now that's largely defined this overall shape. And if I really want to get tricky with it, I can make it collinear to that one so they stay the same height across the board, right? And now I don't have any dimensions on this one. As I jump over to the sheet metal tools and just say base flange tab, I can set my overalls, right? Because I've already done a piece of sheet metal, it's assuming I want the same gauge again. You have to check the override default parameter button if you want to change gauges within a weldment. But it's designed to try to get you to use the same stock over and over again inside of here, right? Because that's going to be easier to order and things as well. So I'll stick to the defaults there. Now that just put a floating piece of metal out in space at the moment, but I can come in and edge flange, miter flange, do whatever I want to do off of that and kick off the flanges. If you're not familiar, you can also switch over to, like, say, up to vertex and choose an individual vertex, and that's one way I can get a flange in there without any dimensions on it at all. You can also do offset from positions as well. You need to be a little careful as you're creating flanges inside of here relative to where the metal is lining up in here, right? So as I created that particular flange, these settings down here are dictating that, right? So I've got a sheet metal edge relative to the edge of that weldment, then I'm kicking inside of that to do my bend so that that comes and touches the metal. If this is set just that button off, this piece of metal does not fit inside of there anymore, right? I'm now that stock thickness off, and then this, even worse, would put me the radius plus the stock thickness off relative to that, right? And there's some tricks you can use kind of after the fact to make sure things are bending in the right directions. You know, an assembly has some collision detection options where multi-body parts do not. I have used some tricks of combined common to get me geometries as well if I want to check kind of collision detection on a sheet metal weldment body. But that's one way to go about creating sheet metal inside of this environment. And it has some pretty obvious benefits. Again, if I resize that table, that piece of guarding is going to come with it because it's just snapped to all those edges, right? And as a designer, I know this thing's 12 inches long, and I have no idea how big it is otherwise, which is kind of nice from a design perspective. That said, you know, keep in mind your press brake, whether or not you can fit that thing on your press brake, you know, whether or not it's got to get cut up and welded back together again afterwards. You know, they do have their limitations with respect to tooling, so you do want to pay attention to that. You know, down here, when you look at this foot, you know, one of the big topics we talked about earlier was whether or not this foot itself down here that accepts the caster should be in the weldment. Should that be its own part file? Should we track that separately? Should we stock that item, right? And herein lies a downside to this methodology, right? I now either have to mirror this body around, I have to draw it again, you know, I've got some work to do here where in an assembly, insert part, drop this thing in, you could have mate references on it that automatically find home on it. You know, there's a lot of different ways about that. In this case, because I'm in a weldment environment, you know, mirroring might be the easiest way to go. I'm going to mirror the foot and then, you know, go and show you the insert command on the actual caster so you can see both sides of that. If I go and hit mirror and I'm grabbing my body to mirror, I'll go ahead and mirror this one over this way. There is no way to my knowledge to mirror in two directions at the same time. It has to be two separate commands. So if I want to mirror that foot going the other direction, I've got to come and grab the mid-plane on that. If you do not have a mid-plane on this, and it's one of the reasons I use that centered rectangle to start with, right? If you don't have a mid-plane, SOLIDWORKS has made it very easy to get one. If you hit plane, grab the outer perimeter edges, faces, it'll automatically split the difference and give you that mid-plane option, right? It'll do that on non-parallel members, right? It does bisect angle automatically as well, which can be pretty handy for a weldment as well. So I'd have to mirror on the other direction to get the feet, but keeping things rather simple. I'm going to go and bring in that insert part idea as well. So we spoke to this earlier, and I can't honestly tell you I think it's a great idea, but I want to show you all the different methodologies here, right? So I'm in a part file, and I can go to insert another part into this part, right? So if I do that, browsing out to my hybrid weldment environment, I've got that caster I downloaded direct from MacMaster and made 0 changes to, right? Which I also don't recommend. But when you hit open on that, it's going to bring up the dialog for dropping that part into the assembly. One thing you want to watch over here is this transfer set of options. So this is what's coming across during the insert operation. That part file could have 10,000 axes, planes all over the place, reference points, miscellaneous geometry and surface work. All I care about is the solid bodies, right? So I've got just that box checked up at the top, right? But if you want the axes, you can bring those in. You can choose to bring in the planes that are there, right? Those can be pretty useful for locating things. Locating a round object in a multi-body part environment can be rather cumbersome if there's not a hole for it to fit in, right? Because there's nothing real tangible to touch as you're moving parts around. Locating this part, it's very crucial that you check this box down here for locate part on the move copy command when you drop it in. Not the end of the world if you miss it. You can edit the feature and go check it again. You can also insert move copy body to get where you're going with this as well. But that puts a separate feature in the tree where if you check this box, it's going to embed that into the insert part command. And now you're editing the insert part command to move the part around. So I usually drop it someplace relatively close. And then it pulls up the locate part dialog box because I checked that option. There are two different functions within locate part. There is this translate and rotate functionality, and then there's what they call a constraints functionality. SOLIDWORKS has an odd behavior of naming things mates and constraints and relations all over the place. And they're really all the same thing, right? They're geometric relations between components. Translate, rotate works very well if you know where you put this and where you want it to go, right? So if this thing came in at a compound angle at 30 degrees and I want to rotate it, coming here can be a really effective way to just kick this thing down at a 30-degree angle. But I have no idea where I dropped this caster, and I'm just trying to get it to land inside of the tube, right? So this isn't probably my best option. If I go over to the constraint side of things, you've got what I would argue is the basic mates in SOLIDWORKS, right? You've got coincident, parallel, perpendicular, tangent, concentric. This one here is distance, angle, and then you can flip the mate alignment. As I mentioned in the breakout session, this is not as good as mating. It's a little clunky, right? If I come in here, I can say, well, I'd like this bottom face and this edge of the caster, and it just immediately snaps there. There's no fancy animation of it going there. You can't really check mate alignment all that hot, and it put it off in space over there, right? The other huge mistake I see people make, they go up and hit the green check, which does not what I'm looking for, right? That says I'm done locating part, and now this caster's still off in space someplace. So unlike other commands, you have to actually hit this add button, which now adds that mate to it, which they now refer to as a mate when it was a constraint earlier. And then you can bring it over into the hole relative to that, right? So if I'm going to take and grab this relative to the hole I punched here, and that'll bring that over. I didn't take the time to clear for the hole and the pin that goes in there, and quite honestly, that caster diameter is a little too small to fit in the end of that tube, but I wasn't going to redo the entire weldment because I didn't grab the right part. You probably should. So overall, that's how you're going to actually bring an inserted part into that assembly, right? And green check that, finishes, and puts that component in place. One of the things I mentioned in the prior session, though, is you're not going to get any kind of movement or motion out of this thing, right? This caster is designed to have a bearing and swivel in it, and I'm not going to get that in a multi-body part environment. Right? Multi-body parts are static in nature, right? And at the end of the day, I don't necessarily care on a caster, right? You may very well care on a gate, on a swing, on a hinge, you know, depends on what you're trying to design there. A lot of weldments still do have some moving components on them. And just because in real life it moves doesn't mean you have to make it an assembly. But if you really want to see that movement, showing your customer how things swing and move, you're probably going to want to do that in an assembly level with mates at that point. And that's more the hybrid method I'm going to speak to next. Anybody have any questions on that methodology at this point? Yes. So MacMastercar typically makes part number configuration name is what I've seen on most of their components. And configuration is what it's dropping into the assembly. You know, if you want to get back to a different one, you know, it can be kind of difficult. But in the properties within this, I've now got two of some of these bodies in here. And one thing that I'd like to point out that's also a downside here is notice that it brought in solid bodies, right? This caster is actually coming with the wing nuts, the caster itself, and the wheels as separate components, which is likely not the way you're going to order them, right? In fact, I downloaded one part number from MacMastercar here, right? So again, something you want to watch out for there. So I guess stepping back to your question, first thing I would have done to really remedy this problem, I go join all three of those bodies together inside of that single part file environment. You can go to insert, feature, combine, and add, and that'll join all those bodies together. That'll eliminate the fact that I'm getting multiple different, you know, bodies inside of this environment. Then on that finished product, you can go to properties and you can make a custom property of part number that I can get to show up on a print somewhere. Full-blown extracting that part number, you know, you're probably better off calling that part off from its original state at that point, right, and tracking it that way. Again, you don't get a ton of tracking with a weldment, unfortunately. So I do find that the individual part numbers are better handled in an assembly in a hybrid environment in that respect, which I think is the conclusion we all drew in the panel earlier, but I did want to show this methodology just the same. But to my knowledge, the only real good way to do it is to set a part number here and key in whatever that is, and then you can get that show up on a print downstream. You can. That's kind of speaking to what we were getting at earlier with now I've got this multi-sheet drawing. I need a relative view that's going to get me that individual body. And then there's additional button clicks that I have to step through to get the flat pattern out of that, right? Which is in a lot of cases what companies are looking for on that sheet metal part. Is it possible? Yeah, pretty clunky. You know, there's a lot of button clicks to that. You know, if that's something you guys want to see, I can do that. You know, I'm at this point, if we jump over to, let's say, the print side of this, I thought I already had one. Combo. Take a look at what it calls off here relative to that. So I took the time to just lay out a quick bill of materials out of the box and call off that individual piece with the auto balloon function prior to the demonstration. Now, auto balloon works relatively well, but it's going to be a slave to how many bodies are in that file, right? So again, because I did not take the time to join that McMaster car part, it's calling off the individual components down here as different parts relative to the BOM. You can go down the road of a sub-weldment as well. I mean, it's going to try to join that. Not 100% sure how it balloons it. Haven't tried that. If it breaks down into separate balloons, but that's another method you could use. The downside I find of sub-weldments is they're not really reusable in other weldments, right? So that'd be great for this caster and this weldment. It doesn't solve your problem in the next one, right? So did it solve your problem? I don't know. I think the point of that caster is you're going to use it over and over again. So you know, it got all my item numbers, it got my quantities relative to that. It's missing a pretty fair amount of description, right? And I purposely left this stuff off to show you guys how to back populate all this information if you want to go down this method. So the reason that description shows up for the square tubing is because it's built into the original weldment profile that was used to create that multi-bodied part, right? So when I swept that 2x2 by quarter, right, jumping back to that, if I go back and look at that independent feature, the particular profile that was chosen when this got created has that property on it, on the hard drive. So this particular size right here has that property on it automatically. So if I go look at the properties on this, descriptions here, and that's filled out there, right? On an individual weldment basis, you could go and override this to say whatever you want. If you wanted to change it across the board, so every time I use 2x2's tubing, I want to call it out differently, you should go to the weldment profile file and modify it there because it's pulling it in downstream, right? So if you don't like TS 2x2 by quarter and you want it to say something else, you need to go modify it at that point, right? So that's where it got that. We spoke earlier about it automatically getting length, right? That's the top option here. And then we also mentioned that there's an angle 1, angle 2 relative to that, and it's getting the zeros on both sides of that. It's grabbing material, quantity, and total length as an automatic functionality in SolidWorks now. Material is by default coming from the weldment material. So that's a single part file. If I set that to plain carbon steel, all bodies within this weldment default to plain carbon steel. You can override that if you want to. If you're actually going to weld that, you better have a specialist to just weld similar metals. But you know, it makes a lot of sense with respect to that purchase component. You may want to override material to say perch or something like that. So doing the material side of that, if I set material here to my plain carbon steel, that set all the bodies to that. But drilling down inside the individual bodies, you can actually set material here separately for the individual body, and the body will override the part level materials downstream and force the properties onto that from the weldment cutlass folder level, right? So why am I missing properties on a bunch of these other things? Well, the default description on sheet metal is sheet. So you have to go and type in this stuff or potentially do a bounding box or something. I definitely believe there's some room for improvement here on SolidWorks' behalf. I'd like to see some intelligence get built into some of what's going on here. You know, we've got gauge, we've got a few other things, and I can go and override this to call out certain things within that. You know, bend radius is in here, the number of bends, things like that. But in my opinion, these aren't really things that I'm going to call out in the description, right? You know, sheet metal thickness I could see. You know, for the most part, that's probably good enough. But from what I've seen, I can't get that to continually default to that. So it's something you have to operate, you have to override all the time, right? So if I override this to be my 060, you know, thick sheet, when I jump back over to the print, that's going to update there relative to that because that's where it's pulling it from, right? Length doesn't auto pop on a sheet metal part, right? Length is purely something coming from a structural member. So most companies I find just leave length off of the sheet metal, might put in a stock size relative to that. But I think this kind of begs the question of should all of this stuff be in this file, right? Because you're not going to get a very succinct cut list relative to this, right? You know, the cut list functionality is very driven towards stock length and the overall length that it needs relative to that cut. And you can try to force other materials and components into this list, but it's very difficult to get everything to land in every single column relative to what you want. You know, when you look at it from more of the hybrid methodology we talked about earlier, you're more going to see just the structural steels on this list, and then I'll show you a bill of materials maybe on a separate page that's breaking out the sheet metal, things like that downstream. Customizing columns here. So it out of the box does item number, quantity, description, and length, right? If I was looking for angle or something else here, you just simply right click in between these two, insert column to the right, and then it's going to pull that up. Over on the left side of the screen, I can go get to the defined settings. So I've got item number, quantity, cut list item name, right? In this case, cut list item name is the folder name, right? That it's residing in, which matches TS 2x2x1/4, but I could turn that into legs, side rails, upper rails, sheet metal guard, things like that, if you wanted to get another kind of descriptor on there relative. You can also go to cut list properties. So this is how I can pull all the property lists I show you in the individual cut list. So that's where length, angle, measure, you know, materials, things like that are set, right? You can't really pull off a column representing two things. And that's where this kind of falls down, right? I can't say, you know, go pull length for cut list members, but go grab a dimension for sheet metal parts or something, right? So you end up with these disjoint columns if you're trying to do all this in one place, right? But I'll just throw material on there for now, for example, right? And set that on the parts relative to that. Once you get a weldment cutlass at this point to have all the columns, the sizing, and everything that you're looking for, I'd strongly suggest you right-click in the corner, do a save as, and then you can save off a cut list template, so you don't have to continue to do this downstream, right? If you always want those columns at these sizes, save that off. There's a point that SolidWorks is pointing to that, looking for that overall template with respect to that. So that's how you're populating a lot of those properties. You know, if I wanted to get part number downstream onto a print, I can pull that column relative on here. You know, the downside is, did you want part number on all the structural members too? I don't know, you know, and if not, I know I need a column that has just purchase part numbers in it and everything else is blank. It's not the end of the world, but it's not super clean looking either, right? So that's kind of some of the ins and outs of doing it all in one file. There's some appeal to it. You know, I think that one of the huge appeals to a weldment that makes a ton of sense is building all this stuff in one place because it's super fast, it's easy, it updates downstream very fast. But one of the points I think we were trying to make in the panel discussion is that's not terribly consumable when you hand that to somebody to build it, right? You Did you? Sure. Sure. So the individual sheet metal body would kind of lend itself to the relative view. So if I do insert view, drawing view, and then it'll be relative to model. So if I go ahead and I'm clicking on the independent view, what was mentioned earlier was that it's going to let you align this particular part relative to those views. So if I say front and this is the right view, and then here it's trying to grab the entire part, you want to make sure you're going to a selected body and grab the independent piece of sheet metal off of that, which is going to give me that independent piece of sheet metal over here. I can move it to a different print as well. And then if I do a projected view on that, you can see it's still the bent piece of metal relative to that. The independent view itself, you can change what bodies things are pointing to now. This is the last couple of years, I think they added the functionality to be able to reselect bodies. Otherwise it was delete, do this again. Relative to that. One of the things that was brought up earlier was that we could potentially right click on this and rotate it relative or make that horizontal. And I don't even know what right click he was talking about, to be honest, off of that edge. Alignment's gonna do, might have been what he was getting at. What's that? Still didn't hear you, sorry. Zoom. So that's the angle here he was talking about, like kind of tweaking 30 degrees. But a user had brought up, can we rotate a relative view, making this line just horizontal? I don't necessarily. Potentially. Alignment. To see the angles relative to that. I mean, you can also grab and twist the thing, but so not sure that's possible on a relative view with respect to that. So getting the flat pattern out of this thing, like I said, it can be a bit tricky. This is going to an independent body. Now, if you look at the Weldment itself, you can right click and toggle flat display, which is going to give you that preview of what this thing looks like unfolded, right? But of course that disappears as soon as you click off in space. You can right click and you can flatten, right? Which does give you the flat pattern of that piece of sheet metal and isolate that independent body relative to that, right? And then as you get out of that flatten command, it's going to go back to the entire weldment. I have seen a number of issues on a very complex weldment with a lot of sheet metal in it where it doesn't really unfold everything correctly. Where if I have that exact piece of sheet metal by itself in its own part file, everything seems to work fine. But I've definitely seen some odd behaviors with flattening that independent body. And then you've got the overall, configurations side of things as well with respect to that. Now, the Weldment itself is making a config. Display states can kind of hide show things as well. When you go to flatten here, it's not really auto-genning anything over here. If you're familiar with the way sheet metal works, when you say, make a flat pattern out of this, it's making a derived configuration of that independent piece of sheet metal. That's what gets referenced on a drawing, right? That becomes a little trickier to do in a multi-bodied environment, although it is possible. I've seen people tackle this in a couple of different ways. You can certainly unfold the bends, isolate the body to be able to get an independent flat pattern. That's one way to do it. Some of the SolidWorks documentation has some of the other side of things, but I guess my big thing is, am I really trying to get it on a print, right? Or am I just trying to get it to a DXF file or a laser, right? Because if I'm trying to get this out to get laser cut or something, I don't know that I need the flat pattern on a piece of paper to do that. And that is definitely possible right from the 3D model. If you go to export DXF here, you can save that particular file. When you go to options, you can choose what particular option gets saved off, what version of AutoCAD and things it's saving off relative to the DWG. That becomes very useful when going to old laser formats, right? So the other thing you want to watch is splines versus polylines here. Some old lasers really don't like splines and will just crash or burn a corner to nothing when they go around a spline. So they prefer polylines where it's breaking that edge down. And there's some options within that. After you hit the save button, which is kind of odd, I think, then it comes up and says, what are you exporting? So I'm not really sure what it saved in that DXF file up front. I would assume that save should happen after I choose all this. But you can choose sheet metal here, and then the flat pattern itself, the geometry you want, whether you want any of the bent line edges, and then you can say, you know, the output alignments relative to that. You know, I find giving, if you're going to outsource fab this, giving somebody a flat pattern can be kind of a dangerous animal, right? At the end of the day, what you likely want is the bent part to fit on your assembly, right? And if you give them the flat pattern, you're now, in telling them they have to manufacture to your flat pattern, they need to know every one of your bends, what your bend calculation was relative to that, right? And there's, what, at least a half a dozen formulas to come up with that, right? So I don't know how much I love the idea of giving a flat pattern on a piece of paper, you know, but with respect to that, you know, I would assume the counterpart that was here, you know, for doing the sheet metal side of things is looking for your bent part, and he's unfolding the blank relative to that for manufacturer. So this will end up putting out a single or multiple file if you're doing additional bodies to export within that. What I have found this also very useful for is burnout parts, right? If I've just got a flat plate and I got to burn out all these holes in it, just right click and do this on one of the faces, and that'll get you that top face with all that burnout geometry in the DXF file output as well. Does everybody have a full need to get the flat pattern onto a piece of paper in a multi-body environment at this point? What's that? Sure. Gotcha. It's been a little while since I broke it all the way out into a flat pattern on the sheet. Yeah, I know that one. I thought there was another way to do it. I thought at one point, based on what kind of view it was. I don't have it over here. Are you talking about the relative view coming over? Being the first one? I remember there being like what view this was, and you could like pull down and choose. Do model view. Then you got to select the body. You grab the sheet metal, and then here, thank you. You can get to. Do you? Oh, no, you can change it here. Maybe. Control Q. There we go. Yes. So you can check that box after the fact. Thank you. So yeah, that'll get you a flat pattern out of independent sheet metal piece as well. This one here is still showing bent at that point. Can I do that again? Yep. So it was model view. You're grabbing the entire combo weldment, hitting the next button, selecting the body, grabbing the sheet metal body, hit the green check, and then down here you can choose the flat pattern of that. And there's a checkbox there for flat pattern. on that independent sheet metal part. Now that sure looks like the bent part with a radius on it to me. There you go. Just check the box again. You'll be all right. Gotcha. Mm-hmm. Sure. For sure. I spent a lot of years in a similar situation. I was at a sheet metal stamping house that had 2D CAD, and they just sent us this bent part. And I don't know if anybody in the room's done the math on that the hard way, but when I saw SolidWorks hit flatten for the first time, I changed careers. Literally, like I'm doing the wrong job, man. Because it's an offset of the inside bend radii with a K factor, right? And depending on what kind of material you have, I mean, that can be all over the place. So, but with respect to that, like the overall length on this piece of steel is not an exact science. You know, it is more of an art form than anything, right? Depending on what K factor I choose around that corner, if I use a bend allowance or a bend deduction on that piece of metal, I'm going to get a different overall length, right? So there's some credence to making you do that math, no offense, because we're going to get to the bent part that I want in the end, and having you figure that out lets you manufacture it the way you want to get there, right? The flip side of that, though, is if I give you this flat blank and then you change the bend radius in the corner on me, it's not the same part again, right? So, and I think that kind of speaks to the design intent on with respect to that. So, right. Sure. Yeah, the goal is to show you guys the ins and outs of both sides of it, right? So, you know, so that's the overall premise on that. And I've gone down the road of the independent, config, suppress all the other components or hide all the other components and unfold a piece of metal as well. Obviously, more button clicks. The other thing you want to watch with that methodology, bend lines are out the window. When you unfold a piece of metal, you're not going to get the bend lines. You're not going to get bend notes, right? It's not going to tell you down or up on those notes relative to that either. So that's purely getting you perimeter on that part. One thing that is worth pointing out in the properties, and this kind of goes to the weldment bead side of things as well, is the individual cut list items for those pieces of sheet metal do have some interesting properties in them for laser cutting. You've got some overall bounding box sizes, which is giving you your effective gross, sizing. And then you have bounding box area versus bounding box area blank. That is your net and gross on that burnout, right? So it's giving you the overall and then all the carved out areas relative to that. Your cut length outer and inner, right? That's actually giving you outside perimeter and the inside perimeter of that burn, right? I've got 0 on the inner because I have no holes in this thing, right? If I punch a hole in that piece of sheet metal, the inner climbs, the outer stays the same. And then it kind of gives you a number of cuts and bends relative to that. You can take that as far as the costing module to figure out what a piece of sheet metal costs and things. Not exactly what I'm here to show you, but it's worth mentioning. At the very least, you get an idea of the inches per burn. And if you're going to have that laser cut, it's worth knowing that information because that times material thickness and size is your answer for a quote, right? So that's at least a good start on a quote relative to that on that process. So I cover both of them. I think so. Any other questions on that idea at this point? So one thing I would like to point out, I have a very simple weldment here. I've seen people take this to extreme levels in one file. I've gotten weldments that are just like 60 meg files. They've got hundreds and hundreds of weldments and pieces in them. And one thing that we didn't really bring up in the sessions earlier that's very much worth noting is SolidWorks is processing all this stuff linearly down a rebuild tree, right? So the more you add to this, the longer the rebuild time is on this entire weldment because you put all your eggs into one basket. And if you look at this from a hybrid methodology of an assembly plus all the welded components, you're mitigating where that rebuild occurs relative to the file at the top level, right? So the assembly is going to rebuild its mates. It's not going to rebuild the entire feature tree history of the weldment, right? So something to consider, especially on large performance weldments. If you've gone down that road and you have some beast weldments that you want to or have to keep dealing with respect to that, the rollback bar will take you back in the tree prior to those other features happening, right? So that you're not thinking about those in processing power. If you're not familiar with it, there is an option starting in 2012 called Enable Freeze Bar. It's off by default. Highly recommend turning this on. It's really handy. That freeze bar will give you an orange bar at the top here. And if I bring that down, it's going to lock out and freeze all these features so that the features aren't getting rebuilt during a rebuild operation. And the reason I bring that up relative to the conversation of the linear rebuild that occurs here is if you now look in between the blue bar and the orange bar, I'm saying these haven't happened yet, blue bar up, don't think about these, orange bar down. So now in this monstrous weldment, I'm thinking about 4 features depending on where I move these bars, right? And I've done that a lot with complex tooling and designs and things like that I've done in a multi-bodied environment as well. And that can help to mitigate the performance hit you take on a very large weldment. That said, before you ship this to the shop floor, roll those bars top and bottom, hit Control Q, go get a cup of coffee, come back and make sure it's all good, and then get this thing out to a print run downstream relative to that. So that's kind of the all-in-one, what I call the combo weldment. Bringing up the same file again relative to the more of a hybrid environment. So again, I've got pretty similar assembly here in this case. I can get the individual parts, I can get the individual assembly here. And if I jump back to this thing looks visually identical to the part that I just had on the screen, the exception being the feature tree, of course, right? Because what I have here is a part file with just the welded steels in it. I have a sheet metal part completely separately made. I have the plate part separate on top of this thing. The caster plate itself is a separate file. And then, of course, the independent part file that is the McMaster car part dumped in. I'm assuming at this point nobody really needs to see how I mated this all together, right? Nothing special about that relative to that process, right? But that's the work that needs to occur with respect to that. The main reason for bringing it up was to kind of show the way this breaks out relative to a bill of materials now, right? So the weldment cutlass job is to break out and show all those independent pieces of steel, right? The bill of materials job is to call that off as one item, and then you're going to have a separate table, arguably, for the weldment side of things. So if I look at this, I'm calling off the sheet metal, I'm calling off the plate, the caster. The weldment itself is just item number 1, right? And if I go over and look at the BOM, I have just that, right? It's the weldment as a part file, the individual parts, and it got the item list the way it does all bill of materials in the order that you put them into the assembly. That is default. You can always rearrange them, right? And then custom properties, the way I'm hoping everybody's knowing and using, will populate description on this table, right? They're not specially baked into the folders, but they're custom prop on the part files themselves, right? So where does this fall short? Well, still have no idea what these pieces of the weldment are inside of this BOM, right? It doesn't really do both, right? So I want to show you a couple of methodologies to tackle that. Sheet 2 here, I've made the actual weldment by itself, right? And then put a cut list on that, right? And as I was doing so, I went to go balloon this and it caused me a problem. And I thought about fixing it, and then I thought, you know what? It's probably just worth leaving in the demo because you're going to run into this if you go down this method, right? So here, if I go to auto balloon, well, it looks like I already did fix it. First time I did this morning, and it looks like I already set the view to fix this. The auto balloon function gave me nothing at all. And I'm like, oh, that's odd. All right, so then I went and manually ballooned it, and it called off each piece of steel as 1. Thought about that for a second. I'm like, well, what's going on here is the view is actually tied off to the bill of materials on page 1, right? And because that's all part of the weldment, I got detail 1 on page 2, right? And one of the comments made earlier was that doing a second sheet in SolidWorks is kind of a pain. Well, those are some of the things you run into, right? So what I did to remedy that, and I didn't think I saved it, is a right click on the view, go into properties, and down here you can tell it what table to link to in the properties of a view, right? Very, very important for getting the right balloons to the right table if you have a multi-sheet drawing, right? So the big key to that is you want balloons linked to the table, and you want the weldment cut list on this page, not the bill of materials, otherwise they all call off 1 relative to that. So that's one methodology where now I'm getting the independent pieces of steel, 1, 2, 3 across here. I get the tube descriptions and things relative to that, the way all weldments will work. Then on page 1, I'm going to have the bill of materials relative to that. Which time we got? Done? Fair enough. So that's as much as I could stuff into the time I had. So, it's a good question. I believe they overcame that limitation. Yeah. I thought you could do an explode on that, though. Double check it. Yes. 2017 can do an exploded view on a weldment. I don't know exactly when that came out. It's relatively new. Last couple of years, 16 or 17. I don't know if 15 did that. So, any other questions? Thank you. Somebody else is probably talking different part of Yeah. One thing that Adobe has done incredibly well is they've made that transcend operating system. So I think they've really gotten to the part of it. We're starting to leverage that now.
All right, everybody, we've got prizes and giveaways coming, so if you all head on back in here, we'll get that moving, and we'll wrap the evening up. So, come on back. Oh yeah, if y'all don't have a raffle ticket, head on back to the back table, and grab, need a raffle ticket if you want to win the Lego blocks for adults. Oh, down here. Anybody not have one? Fine. All right, if we're all good, which is first? First come, first serve. All right, last 3 is 608. 608. Here we go. All right, next victim, 559. 559. No 559? Always comes. Okay. All right, after 559, we got 581. 581. There he is. All right, 582. 589.